Hello everybody. This video is another one on variable acceleration, and it is going to cover the 11.4 section on page 188, which is using integration to solve problems involving variable acceleration and variable velocity. So here is the page using integration. Going back to here, variable acceleration. If you remember, velocity is a rate of change of displacement, so v is ds by dt. Acceleration is a rate of change of velocity, so a is dv by dt. And so if you want to go from s to v to a, you differentiate. And because integration is the reverse of differentiation, in order to go from acceleration to velocity, you integrate the velocity. And in order to go from velocity to displacement, you integrate the velocity, which will be given as a function of time. Okay, so I'm just going to go through example 7 on page 189. Here we have a particle travels in a straight line. After t seconds, its velocity v is given by v is 5 minus 3t squared. Find the distance travelled by the particle in the third second of its motion. So that would be from time equals 2 to time equals 3. The first second is 0 to 1. The second is from 1 to 2. The third is from 2 seconds to 3 seconds. So we have v equals 5 minus 3t squared. So in order to get the distance, so we want to integrate. Integrating will give you the displacement. So we have the displacement s is the integral of v dt, which would be the integral of 5 minus 3t squared dt. And we want to go from the second to the third, from t equals 2 to t equals 3. To do this, you can just integrate between those two values. So that would come to, if we integrate 5 minus 3t squared, 5 goes to 5t, t squared of course goes to t cubed over 3, so multiplying by 3 that would be just minus t cubed between 2 and 3. So that is equal to 15. If we substitute in 3, we have 5 3s are 15, minus t cubed, which is 27, minus, substitute in 2, we have 10 minus 4, giving us 15 minus 27 is minus 12, minus 10 minus 4 is 6. So that will give us okay, I've just spotted a mistake here. 2 cubed is of course not 4, it's 8. So let's make that 8. Oops. 2 cubed is 8. So we have minus 12 minus 10 minus 8 is 2. So that would be minus 14. It's a displacement, meters. So it's negative. So that cannot be the distance. The distance is always positive. So if you see what's going on here, if we were to sketch the graph of v is 5 minus 3t squared, then that is going to look like, if we have the whole thing, 5 minus 3t squared is like that. It's a parabola minus t squared. And of course it's got 5 minus 3t squared, so we would translate it 5 that way. And so if t is 0, that would be 5. And if move that. Okay, yeah, so I've redrawn this. So it crosses the x-axis at 1.3, and so you can see where time at t equals 2, there's t, that's s, so oops, v even, v. So where t is 2 and where t equals 3, the area under the graph we can see is negative. So that is why we have minus 4t. The distance, of course, travelled is just 14 meters. It's the positive value. So what's going on here? We can see that the at time t equals 0, the velocity is positive, and so it's moving in that direction, in the positive direction, but it's slowing down, and eventually, well, I shouldn't say there, eventually the velocity will get to 0 at that point there, so that it will stop, and then it will go that way. So it'll be doing that. And so the displacement, the displacement when it goes between 2 and 3, it's between two values that way. So the displacement would be, the change in displacement would be negative. It's moved from this point there, we could call that point 2, and this point there where t is 3. So in the negative direction, so that's why you would get a negative displacement. Okay, now I'd also like to go through question 12 on exercise 11D on page 191, because this involves having the acceleration in terms of time. It says a particle travels in a straight line such that its acceleration at time t is given by a equals 6t plus 2. When t equals 2 seconds, the displacement is 10. So when t equals 2, the displacement is 10. So t equals 2, displacement equals 10. And when t equals 3, the displacement is 38. Okay, now we want to find the displacement when t is 4. So we need an expression for the displacement. In order to get from acceleration to displacement, remember s to v to a is differentiate, and from a to v to s is integrate. So we need to integrate a to get v, and then integrate v to get s. So v is the integral of a dt, which is the integral of 6t plus 2 dt, which is equal to, well, t of course goes to t squared over 2 times 6 is 3t squared, and 2 will go to 2t. But this is indefinite integration, so we need to add the constant c. And the constant c is what we would discover, well, if we had a value of v for a value of t, but we haven't got that. What we've got here is two values for s at two different values of time. So I need to carry on integrating to get s, because we have s is the integral of v dt. So that is equal to the integral of 3t squared plus 2t plus c dt, and c we haven't yet found. So integrating that, t squared of course integrates to t cubed over 3, so multiplying by 3 just gives you t cubed. 2t integrates, well, t is t squared over 2, so that becomes t squared. C is some constant, we don't know it yet, so we better write ct, and we've got to yet add another constant because we're integrating. So we had two constants of integration here, and that's because we've integrated twice, so I'm adding d. But that's okay because we had two conditions. We know at 2 points in the motion, the value of the displacement at 2 points, at 2 times. So we can substitute in both of those to find c and d. So t equals 2, s equals 10 will give us 2 cubed 8 plus 2 squared 4 plus 2c plus d, and that is equal to the s, which is 10, and t equals 3, s equals 38. So we have 3 cubed 27 plus 3 squared 9 plus 3c plus d equals 38. So simplifying that, we've got 12 plus 2c plus d is 10. So I could make 2c plus d equals 10 minus 12. And I've got 3c plus d equals, well, I've got 36 plus 3c plus d. So that equals 38 minus 36. So that is 2, and that is 2 also. So we've got 2c plus d equals 2. Oh, yeah, that can't be right. Oh, I should say 10 minus 12 is of course minus 2. So that's minus 2. That's minus 2. And 3c plus d is equal to plus 2. We can subtract I'll call that 1 and 2. So 2 minus 1. 3c minus 2c is c. D minus d is 0. And 2 minus minus 2 is 4. So c is 4. Substituting to 1. 2c is 8 plus d is minus 2. So d is minus 10. So we have a expression for s, t cubed plus t squared plus 4t minus 10. So s equals t cubed plus t squared plus 4c minus 10. Okay, so we have the displacement. Now we need to find the displacement when t is 4. So if t equals 4, substituting, s equals 4 cubed, 64, plus 4 squared, 16, plus 4 times 4, 16 minus 10. So that's 64, 80, 96 minus 10 is 86 meters. And also we need to find the velocity when t equals 4. Well, to get the velocity, we can go back to our value of v, 3t squared plus 2t plus c. So v is 3t squared plus 2t, 3t squared plus 2t plus 4, and so v equals t equals 4, v equals 3 times 16 plus 2 times 4 plus 4, 48, and 8 is 56, equals 60 meters per second. Okay, so that is that. So now you should do exercise 11D on page 180.